All right, so this next page is Simpson's paradox. Unfortunately, the page that's in page 46 of your note spiral. Please print out the blank Simpson's paradox from the Google Classroom. We're replacing what's there with this one. So anyway, page 46, please print out the new one from the Google Classroom. Well, Simpson's paradox arises when two or more subgroups are combined to form a single group, and there exist significant differences in the sizes of the subgroups and the proportions in each group differ, which cause the combined grouping to appear to contradict the results from the individual groupings. Now, quite frankly, that's a bunch of words that probably didn't make sense. So let's take a look at an example, and then I think you'll start to see what I'm trying to talk to you about. So we have two doctors, Dr. Fix and Dr. Patch, and we have their survival rates for their surgeries. So when I look at the data, Dr. Fix had 60 patients die, 190 survive out of 250. Dr. Patch, on the other hand, had 50 die out of 250, and 200 survived. So when we look at the proportion, the survival rate, Dr. Fix had a survival rate of 76%, while Dr. Patch's survival rate is 80%. So based on that table above, I'm like, gosh, I'd like to survive this surgery. I'm choosing Dr. Patch over Dr. Fix, everything else being equal, because Dr. Patch looks like he has a better survival rate. Okay? All right, so let's break that data down a little further. Turns out that data can be broken down a little further, and we have the patients in what they consider good health condition versus patients in poor health condition. So as it turns out, of the 250 patients that Dr. Fix had, 68 were in good condition and 182 were in bad condition. Dr. Patch's shape was 137 were in good condition and 113 were in bad condition. Now, please note, if I add the 137 to 113, I get the 250 that's right there. And if I combine the 68 and the 182, I get the 250. So if I combine these numbers, they're going to combine together to make the original table. All right, so I have Dr. Fix having 8 who died who were in good condition and 52 who died over here in bad condition. So he had a total of 60 patients die, which is what we said earlier. So there's no trickery on my end, all right? Basically, the two tables combine together to make the table above. But when we look at the percentages, look what happens. It turns out that Dr. Patch, 60 of the 68 patients, for Dr. Fix, 60 of the 68 patients survived, so 88, just over 88% survived. And for Dr. Patch, 120 over 137, so almost 88%. So they're really close, but Dr. Fix is doing a little bit better job than Dr. Patch over here. When we go over to poor condition, it appears that Dr. Fix had 130 out of 182, or 71%, and Dr. Patch had less than 71%. So based on this information, Dr. Fix was better with patients in good condition or poor condition. But wait a second. Up here, it did not appear that Dr. Fix was nearly as good a doctor. What happened? Well, what happened is, well, first off, based on this information, I choose Dr. Fix. So this is an example of Simpson's paradox, where a comparison can be reversed when more than one group is combined to form a single group. The cause of the problem is due to the masking or a lurking variable. In this case, the variable that was hidden is the health of the patient. Dr. Fix had a whole lot more patients in poor health. So consequently, you would expect him to have had more patients die than Dr. Patch, because Dr. Patch tended to have more healthy patients, and Dr. Fix had more patients in poor condition. All right? So Simpson's paradox arises when the numbers in each subgroup are significantly different and alter the proportions in this subgroup. In this case, Dr. Fix operates on many more patients in poor condition, and that group has a lower overall survival rate. So it happened because we combined groups, and this will occur when one group is significantly larger than the other groups, and we try to combine them together to make a comparison. Very special case, very cool, will show up on your test. Thank you.